If you've taken a science class before, you're already familiar with the measuring system that we'll be using here. Essentially, we're not using the English system, which we're used to for our everyday lives. And I'm actually one of the few scientists that says, hey, I'm used to thinking in terms of feet and pounds and stuff like that. However, for solving problems, actually, it does make your life a lot easier to use the SI system of units. So you can kind of see in this table, get kind of familiar with these quantities and the unit that's going to be associated with them. We'll be working with kilograms representing our unit of mass. The British unit is actually a slug, not a pound. Length is going to be in meters, where a meter is roughly 3 feet, give or take, and second's not going to change. Something that's different, I'll introduce it when we get to the sections regarding temperature, is temperature is not going to be in Fahrenheit, it's going to be in Kelvin. We can see, why use the SI system? Well, it really does make our life easier. Let's take water as an example. A cubic centimeter of water is also going to be a gram of water, and a liter, a measurement of volume, is going to be 1,000 cubic centimeters, which is going to be 1 kilogram of water in terms of mass. So SI units are actually related to each other by factors of 10. Pretty easy. If we think about, in the English system, a gallon of water, if you're a backpacker, you know that's about 8 pounds or 8.33 pounds. A cubic inch of water is going to be this god-awful number in pounds, and this even less attractive number in ounces. So working in the SI system really does make conversions much easier. So since things in the SI system are very often related by powers of 10, it's actually, we use abbreviations on occasion. For example, suppose I have something that's going to be 1,000 meters. Well, writing 1,000 is kind of annoying sometimes. So I can say I'm going to put a prefix on my unit right here, where my unit is going to be meters, and I'm going to write that using a unit that's a little bit easier to write. So that's going to be 10 to the third meters. If I look at this table of prefixes, I go down here and I see, a prefix of kilo with an abbreviation of K is going to have a value of 10 to the third. So 1,000 meters is going to be 1 kilometer. Other ones that you might be familiar with is going to be, how many gigabytes your hard drive has, or terabytes nowadays. Ones that are common, it's going to be centimeter, millimeter, and nanometer. So the ones that I have arrows next to, just get slightly familiar with them and how to convert back and forth between them. We'll get some practice with that in a bit. Converting between units is actually fairly easy because everything's related to each other by powers of 10. For example, suppose I had a measurement of mass and I said this is going to be 5.8 grams. What I can do is I can say, well, suppose I want to write that in kilograms for some reason. What I do is I say, well, I'm going to look up and I'm going to see that 1 kilogram is going to be 1,000 grams. Essentially, I'm taking this 5.8 grams and I'm multiplying it by 1. However, 1 has different units. Now what I can do is I can say, well, I can cancel this gram out with that gram out, and I'm going to end up with 5.8 divided by 1,000, and now my unit has changed over to kilograms. So I go ahead and I write that out as 0.0058 kilograms. Converting to and from British units, occasionally we'll have to do this. Suppose we have this mountain, it's the mountain on the front of the textbook, and it's going to be 8611 meters high. Essentially what I can do is I can look up and I can say, well, I know I have this mountain and it's 8611 meters high. I can look on the front cover of my textbook and I can see, well, 1 meter is equal to 3.28 feet. Essentially what I'm doing is I'm going to say this expression in parentheses right there has a unit value of 1. I'm multiplying 8611 by 1. I cancel these units out, cancel the meters out, and I'm left with feet. I go ahead and I type that into my calculator, and I get 28,251 feet. So fairly high mountain here. It really helps to pay attention to your units when you're doing calculations, and heck, even if you forget an equation, you can usually figure it out with the units. For example, if you know that speed is going to have a unit in meter per second, it's going to be a unit of distance divided by a unit of time, you can say, well, I know that length has a unit of distance and time has a unit of seconds, so speed is going to be distance over time. When we're adding or subtracting numbers and they have units associated with them, the units have to be the same. It makes absolutely no sense to say I'm going to take 1 meter and I'm going to add that to 1 second. Essentially, I cannot do this because these two objects have different units associated with them. So this is the summary slide for Chapter 1. I generally don't have a whole lot to say on the summary slides. I've talked myself out, if you will. However, for this one, I'll say, the next up in the series is going to be some worked problems. I highly recommend that you not just watch the worked problems, but you actually try to solve those problems on your own beforehand. With physics, or actually with anything, think about playing a sport, baseball for example. You get better at doing physics by doing problems. You get better at playing baseball by hitting balls. That's why we have batting cages, for example. So my worked problems are actually, you can think of as a batting cage for physics. Highly recommend you work as many problems as you want. You get better and better and better at physics, at anything, the more you do it.